this video, we will see some of the electrocyclic reaction under thermal condition. So in thermal condition, normally when you have a conjugated polyene with odd number of pi bonds, it will undergo this rotatory fashion, while if we have even number of pi bonds, it will undergo conrotatory fashion. As I have mentioned before, the easiest way to remember this is when we have an electrocyclic reaction in thermal condition, which is T, and with odd number of pi bond, so it will undergo this rotatory fashion. So I always remember as TOD, TOD, thermal odd dis. While for conrotatory, for even number of pi bond, it is normally opposite to the TOD. So if we have even, it will undergo conrotatory fashion. Okay, let's take a look at this example. So if we have this compound 2E4Z6E 246 octatriene, so what happened is that when it undergo thermal reaction, it will, because you see it has 1, 2, 3, 3 number of 3 double bond. So when 3 double bond, it is odd number and it is thermal. So it is TOD. So when it undergo this rotatory fashion, meaning one clockwise, one counterclockwise. So what happened is that this will be pushed down here while this will go up here. So what you will get is this CH3 is moved here, this CH3 is moved here. So you can see that this 2-methyl group is now at the same side and you will get a cis product. Remember that a product of electrocyclic reaction ring closing, usually you will have one less pi bond compared to the reactant. Okay, and usually odd and this rotatory is when the phase, the light phase is on the same side. Okay, now let's take a look at even number of pi bond. Okay, for example, this is 2E4Z hexadiene, where you have 2 double bond here. Because it is 2 double bonds, so it is even. So if it is even, it is a thermal reaction. So thermal even, it will undergo conrotatory fashion. So what happened in conrotatory? If this is clockwise, this is also clockwise. So when you turn the molecule into clockwise, okay, both of the methyl group will go down, so it will give you a cis product. Okay, let's take a look when you have a trans-starting material. Yeah, trans-starting material. So this will undergo conrotatory also. Conrotatory. So what happened is that this methyl group will go down, while this methyl group will go up. So you will get this one up, this one down. So you will get a trans product. And normally when we have even number of pi bond in electrocyclic thermal reaction, it will undergo conrotatory fashion. And the light phases are usually opposite to each other. Okay, let's take a look at some example here. When we have 2E4Z 6Z 246 octatriene undergo thermal reaction, and another molecule here which also undergo thermal reaction. Okay, let's take a look at A. Okay, A is an octatriene. So when it is an octatriene, we know that it has 3 pi bond. So when it has 3 pi bond, this is considered as odd. When it undergo thermal odd, this. Okay, so it undergo this rotatory fashion. So what happens when you have this rotatory? One will go clockwise, one will go counterclockwise. Group will go down and this methyl group will go up. So what happens? You will get a trans product. Okay, for question number 2, we can see that this part is now in trans position. So when this is a thermal reaction and it has even number of pi bond, and then it undergo a conrotatory fashion, and finally it will give, this one will go down and this one will go up, and finally it will give you a trans product. Okay, there are 3 examples here. Let us work on this example. Okay, let's take a look at the question here. Okay, the first one, we can see that first we need to count how many pi bond in the molecule. So here we have 3 pi bond. So it is a thermal reaction with 3 pi bond, so it is odd. So you know that when thermal odd, it is this rotatory. So we draw the p orbital first, and if it is this rotatory, meaning it is the like faces are on the same side. Okay, what happens is that it will undergo this rotatory motion. So one is clockwise, so one is anti-clockwise. So what happens is that this bond will move here, this will move here, and this will form a new bond in the middle. So when we form a product, we know that we have 6 carbon involved. 1, 2, 3, 4, 5, 6. So we have like this 6-membered ring, and then we have a new bond at this carbon, and then this is our new bond, new sigma bond, which is from the overlapping of the p orbital. And then if you look at the motion here, the CH3, one of the CH3 will go up, one of the CH3 will go down. So it looks like this. Then one will go up. Okay, when we draw it properly, it should look like this. This is at the back, this is in front. So what do we get is a trans product. Okay, now let's take a look at question number 2. So we know that this is a thermal reaction, and then we have 2 pi bond. So 2 pi bond is even. So when it is even, it is conrotatory. So when we have conrotatory, meaning the like faces are opposite each other. Okay, so what happened when it undergo conrotatory? It is either both clockwise or both anti-clockwise. Okay, let's try clockwise. Okay, in this case, the CH3 will go down here. Then this CH3 also will go down here. So we know that this bond will move here and this will form a new bond in the middle. So we see here there are 4 carbons that involve 1, 2, 3, 4. So the end product must be a cyclobutene. Okay, this is the new bond. And now both of the CH3 going to the same direction. So we can draw it like this. Both are in front. So we will get a cis product for this reaction. Okay, for question number 3, the only difference between question number 3 and number 2 is the position of this methyl group. So in this case, it is still a thermal reaction and it has even number of pi bond, so it will undergo rotatory. So what happened is that first we need to draw the p orbital. Because it is conrotatory, so the phase should be opposite, and then it undergo conrotatory. So this bond will move here and it's going to form a new bond here, and then it involves 1, 2, 3, 4 carbon. So the final product should be a butene, cyclobutene. Okay, so if it is conrotatory, you see this methyl group will be bring down, but this methyl group will go up. So your final product should look like this. One will go down, one will go up. Okay, so to draw it, better drawing of this product is one is in front and is at the back. So you get a trans product.